welcome back to my YouTube channel. Today we are going to dive into one of the most interesting algorithm in data structures and algorithms, Radix Sort. Whether you are a beginner taking your first algorithm class or preparing for a coding interview, I promise to make this super clear and easy to follow. Let's start. Welcome to today's topic, Radix Sort. Unlike traditional algorithms that compare elements directly, Radix Sort takes a unique approach. It sorts numbers digit by digit. As you can see on the screen, we process a numbers step by step from digit 0 to digit 1, digit 2, and finally arrive at the final result, completely sorted list. Before we dive into the details, here is what you will learn by the end of this video. First, what we Radix sort is and why we use it. How digit by digit sorting actually works step by step. Why it is called non-comparison sorting algorithm. And finally, its advantages, disadvantages and time complexity. Let's start with the basics. Before understanding Radix sort, let's quickly recap. What is sorting? Sorting simply means arranging data in a specific order. Ascending order, arranging elements from smallest to largest, like turning 5, 2, 8, 1, and 4 into 1, 2, 4, 5, 8. Descending order, arranging elements from the largest to smallest, like 1, 5, 8, 2, 4 into 8, 5, 4, 2, 1. Now, what makes Radix sort special? Radix sort is a sorting algorithm that sorts numbers digit by digit instead of comparing full numbers against each others. It starts at the least significant digit, LSD, which is the ones place, and gradually moves left toward the most significant digit, MSD. Notice how in each pass, first place value 1, then place value 10, then place values 100. The list becomes progressively more organized until completely sorted. Why do we use Radix sort? It is extremely fast for all numbers. It works exceptionally well with large data sets. It avoids time consuming comparison operations, and it is a stable, meaning equal numbers keep their original relative positions. Because of these strengths, Radix sort is widely used in real world software like database systems, banking software, student record management, telephone dictionary sorting, and sorting postal codes. Let's break down the key idea behind the Radix sort. Take the number 593. 3 is the ones place, 9 is the tens place, 5 is the hundred place. Radix sort works in this exact order: ones, tens, and hundreds. Two key terms to remember: LSD, last significant digit, the rightmost digit. This is where Radix sort begins. The MSD, most significant digit, the leftmost digit. This is where the final pass finish. Two, two key terms to remember: LSD and the MSD. LSD, least significant digit, the rightmost digit. This is the where Radix sort begins. This numbers, the 2 is the LSD. Radix sort starts here. Next one, the MSD, most significant digit. the leftmost digit. These numbers, the 4 is the MSD. This is where the final pass finishes. Let's trace a full step-by-step example together. Here is our unsorted list of numbers 170, 45, 75, 90, 802, 24, 2 and 66. Let's see how Radix Sort organized these using buckets numbered 0 through 9. Step 1. Focus on the ones rightmost digit. Let's look at the ones digit of the every number. 170 and 19 end in 0. So this 170 and 90 place them into bucket 0. 802 and the 2 end in 2. So place them into bucket 2. 24 bucket 4. And the 45 and 75 end in 5. So place them into bucket 5. 45 and 75. 66 ends in 6. Place it into bucket 6. So now collecting them numbers back from the bucket 0 to 9, our new list becomes uh, 170, 90, 802, 2, 24, 5, 45, 75 and 66. Now look at the tens digit. Note digit numbers like 2 are treated as 0 to 802 and 2 have 0 in the tens place. So them goes to the 0 bucket. 24 has 2 in the tens place. So bucket 2. 45 and 45 has 4. It goes the bucket 4. 66 has 6. Goes the bucket 6. And 170 and the 75 have 7. Those goes to the bucket 7. 19 has 90 has 9. It goes to the bucket 9. Collecting them again in order gives us 802, 2, 24, 45, 66, 870, 75 and 90. Finally, let's look at the 100 digits. Numbers smaller than 100 like 2, 24, 45, 66, 75, 19 have 0 in the 100 place. So 2, 24, 45, 66, 75, 19 all go into bucket 0. 170 has 1 in the 100 place. So it goes the bucket 1. And 802 has 8 in the 100 place. So it goes the bucket 8. After collecting all numbers from the bucket, one last time look at what happened. Our array is fully sorted in the ascending order: 2, 24, 45, 66, 75, 90, 170, 802. Here is another quick example on screen with 3-digit numbers this way. And pass 1 sorts by ones, pass 2 sorts by tens, and pass 3 sort by hundreds, and boom, completely sorted. You might hear people say Radix Sort is a non-comparison based algorithm. What does that mean? Most sorting algorithms like bubble sort or quicksort asks questions like, is 45 greater than 75? Radix sort never compares two full numbers instead. It simply places elements into digit buckets based on the position value. Because there are no direct comparison operators involved, it gets the non-comparison label. The radix sort does not ask questions like greater than, less than, or equal. It simply places numbers into buckets based on the digit value, ordering its one by one position, not by comparing entire numbers. Therefore, it is a non-comparison based sorting algorithm. Radix sort is also a stable sort. It means if two numbers share the same digit value in a pass, they preserve their original relative order. This property is important because without stability, previous digit pass would be run by later ones. Let's talk about advantages of radix sort. Very fast for integers and fixed length data. Stable sorting algorithm. Non-comparison based means that is efficient. Works well with the large datasets. Simple and easy to implement. Let's talk about disadvantages. Uses extra memory for buckets, not efficient for numbers with very large number of digits, not suitable for floating point numbers, more passes and required for more digits. To summarize everything we covered today, Radix sorts digit by digit from LSD to MSD. It uses 10 buckets 0 to 9 to group elements. It is stable, non-comparison based and best suited for whole numbers. Thank you so much for watching. If this video helped you understand Radix sort, please give it a thumbs up. Comment down below if you have any questions and don't forget to subscribe to Code with Kavindiya for more tutorials. See you in the next video. Bye bye.